Hello friends, this is Praveen and today we are going to learn about the motion. So friends, this is the part second of the chapter motion. I recommend you to watch the part first of the chapter motion before watching this video. So let's start with today's chapter. So today first we are going to cover about the uniform motion and non-uniform motion. So what is the uniform motion? The uniform motion is defined as the object is traveling equal interval of distance in equal interval of time. If let's take a car traveling 10 units in 10 seconds. So 10 meters in 10 seconds and another then after that also it is moving in 10 meters in 10 seconds and it is going to do this forever. So this type of motion is known as the uniform motion. So let me introduce a term which you have heard in the previous class also, which is known as the speed. So what is the speed? Speed is the distance traveled in a per unit of time. So it is defined as distance in divided by time. So in other sense, I can say as a uniform motion as it is moving with a constant speed. So if it is traveling in the 10 meter in 5 seconds, so it will travel 10 meters in 5 seconds. So if I say you now instead of traveling 5 or 10 meters in 10 seconds, now it is traveling 20 meters in 20 seconds. Now can you say this body is uniformly moving? Yes, we can say that, because now the distance has changed, but as well as the speed has also changed. As you will calculate the speed in this, which is defined as the distance by time, so it would be 1 meter per second, and here also it would be 1 meter per second. Here 20 divided by 10 would be also 1 meter per second. So here in all of the three cases the speed is same, so the uniform it is moving in a uniform motion. So if you will have view it in the graph, what will it look like? So let's make a, so here let's on the x-axis let's take the time, and on the y-axis we have taken the distance. So first let's see how does the graph work. If in a distance it is not changing, if it is not moving the distance or it has not traveled any distance, it would be the y-axis line. So but it has started moving and now it is not moving, so this would be this. So now it has moved for some time and now the distance is not changing, so it is in the rest at this position and it was moving in this position. But we know that speed is when the things move. So when the things move, we define to be set this as a speed. So this is a speed. Now there could be a various types of speed in this. A body could go like that way, or it would be traveling in a straight line, or it is not a traveling, it is a straight line. There could be various factors, it could go like that way also. So these are all the different types of the speeds. So but what happens in a uniform motion, that the line is always straight. What do I mean by when the line is always straight? So and now let me mark the reading, that is 1 meter and 1 second, 1 unit, 2 meters and 2 seconds. So this and so on. So this would be 3. So now as you can see that it is traveling the equal interval. So in 1 meter it is traveling in 1 meter second it is traveling 1 meter, and in 2 second it is traveling the 2 meter. So now we can calculate the speed from here. 2 meters it has traveled in 2 seconds, the speed is 1, and it has traveled 1 meter in 1 second, that is 1 divided by 1, that is 1 meter per second. So that this is the diagram of the what the body was traveling. We have seen it in a graph, but not necessarily that is all the components on the x-axis and y-axis match. So let me give you another example. Now the body is traveling like that way. Now is it a uniform motion? Yes, because now it is traveling. Now it is traveling 2 meters in 1 second, and now it is traveling 2 meters in 1, that is 2 meter per second. Now instead of here would be a 3 and here would be 4, now it is traveling 4 meters in 2 seconds. So that is 2 meter per second, and this would go on the 3 it would travel 6 seconds. That is there would be 5 and there would be 6 meters, and in 3 seconds, so 3 divided by 3 seconds, that will be 2 meters. So now also the body is in the uniform motion, as it is the speed is constant here. That is 2 meter, 2 meter and 2 meter. In the previous example there was 1 meter, 1 meter and 1 meter. So these all are the examples of uniform motion. So have you seen the similarity between all of these graphs? The graph form is always straight. The graph form is always straight in the distance time graph. Now what if I tell you, now instead of making up the distance and time graph, let's make up the speed and time graph. Speed and time graph, in this what would happen? If an object is not moving, the speed would be the parallel to the time graph. In this case we will not know that whether the body was moving at the first or not, but now this body is moving with a constant rate. So now the speed is not changing, means the slope, the change in y-axis is not. So means it would be, if it is always a line parallel to the time line, that is the x-axis. So this would always be parallel to the time axis. But now what if the speed starts changing? Or if I take the straight line not parallel to that time, but I make a straight line like that way, or like that way. Now it is moving in a uniform motion? Not. It is not moving in a uniform motion, because now there is change in speed, because the y is changing. It has changed from 0 to 2, and then from 2 to 4, and then 4. So now it is not an example of the uniform motion. So this was what is the uniform motion. Now let's move to the non-uniform motion. So what is the non-uniform motion? When a body does not cover an equal interval of time in equal interval of the distance in equal interval of time. So this is the graph, and here we have is the time, and here we have is the distance. And let's take a body which was moving first 1 meter with 1 second, and then the body moves 2 meters in 4 seconds, and then the body moves that is 10 meters in 20 seconds. Now we have to calculate the speed. We know that the speed is equals to the distance divided by time. So here the speed would be 1 meter per second. Now in this case it would be 0.5 meter per second, and here it would be 0. That is 1.5 meter per second. That is 0.5. So now in these two cases are equal, but one case is not matching. So this is not an example of the uniform motion, or it is known as the non-uniform motion. So how would a graph of such a body look like? So let's take the time as 1, 2, 3, 4, and now take this 2, 3, 4, 5, 6, and so on. So now what a movie was traveling with 1 meter in 1 second. So let's take this point as that. And now it was moving 2 meters in 4 seconds. So it would be here. So when you will join this line, now the line is not straight but it is bending, and it would go like that. If you now I could not plot because of tan it is very high, but when we will plot that, we will see that tan would be, if you will join and extend this line up to the 20 seconds, here would be the 10 meters, but this would be a straight line, but this would be a that is a bend line, so it would look like this. So we know that when a straight line is not formed, until then it is a non-uniform motion. So this was a distance time graph. Let me take an example of the speed time graph. So now what does the body do? The body was first moving with a 10 meter per second. Then it turned to the 12 meter per second. Then it moved to the 14 meter per second. And then it changed its speed to that is 15 meter per second. So is this now a uniform body? Uniform motion body? No, it is non-uniform body because it is changing its speed. So the speed time graph would look like, so where we have is a speed and time. So now speed and time. So these are time intervals. Now it is moving with 10 meter per second. So it is 10 meter per second. Here is 12 meter, and here is 14 meter, and then here is a 15 meters. But these points would lie on these lines, but the time interval is different because at first time it was traveling at a different rate. So now the line would look like this. This is a straight line, but now also it is not a uniform motion, it is a non-uniform motion, because what happens, the speed is changing. That means there would be a change in y-axis, and we do not want a change in y-axis, so it would be the non-uniform motion. So always note that the uniform motion, in which the line would be always straight in distance time, and in the speed time graph the line would be parallel to the time axis. But this could or could not be the scenario in the non-uniform motions. So for explaining the motion and non-motion, I have used the speed word more time. So what is the meaning of speed? In previous classes we have learned about the distance, time and speed. We all know about time. So we all know about time, but what is the distance? Distance is the path you take or the path you covered. So this is known as the distance. But what is the speed? The speed is defined as the change in the distance per unit time. So it could be written as d by t. Now that we have learned about the three important formulas in the previous grade, which is speed is equals to distance by time, distance is equals to speed multiplied by time, and time is equals to distance divided by speed. So these are important formulas because they would be coming in your higher grades, and most of the concepts are based upon these formulas. So now let's learn about the speed in detail. What is the speed? The speed is the change in the distance per unit time. So if a body was moving with covers 100 meters in 10 seconds, then it covers 200 meters more than the initial one in 20 seconds, and then it covers 400 more seconds more than the previous one with the speed of 30 seconds, with the 30 seconds. So now what is the, it has traveled 100 meter in 15 seconds. So what will the speed here? It would be 10 meter per second. Now what will the most students do? They are taking now the 10 meters and the 20 meters together. So if you put 300 divided by 20, this would be the case. Otherwise, what does some persons do? They are adding the both up and down. That means 300 meters in 30 seconds. Or what a person could do is divide this by this. So that is 200 meters divided by 20 seconds. So which among the following is correct? Here are two correct options. This is wrong, but these two are correct. Because I tell you what is the speed? Speed is a change in the distance by time. So there is a 20 and a 30, that would be 30 seconds in total. Or you are taking, if you are calculating the speed of this or the together, this depends. So now it has traveled 300 meters up to here and it has taken 30 seconds. So what is the answer of this speed? It would be 10 meters per second here. But now this speed is of the total distance which a body has traveled up to that. But what is this? This is the speed body which has traveled up to this distance, which fortunately comes with a 10 meter per second. These both are equal, but because it is uniformly accelerating, I will explain the term acceleration in the later part of this chapter. So it has covered an equal distance, or it was moving with a uniform speed here and here, so the answer came to be the equal. But if the body was higher, the speed was higher here and it was lower here, then the answer may vary. So you have to do based upon the question, what is the question saying. So these were the speed. So now what are the different types of speeds we have? Now a speed can be a body, it is not changing its speed. So first point is no change. No change in the speed. The second point we have is change. Change in speed. These further change in speed can be divided. If it is changing with the equal intervals, then it could be uniform, speeding, and if it is not doing with this, so this is called non-uniform speeding. So these are the types of the speeds. Now we are going to derive some important formulas which would help you in the examinations based upon what different questions can be formed on this speed. So we have to keep these three formulas in mind. This is the formula number 1. This is S is equals to S into T, and the third one is T is equals to D by S. So let's move to the scenario 1. What happens if a body was initially moving with 20 meters per second of speed, and then it changes its speed with 30 meter per second. So now can you tell me the average speed, or what was the average speed at which it traveled? The formula of the average is the the sum of the total sum of the observations divided by the total number of observations. But this would not be applicable here, because this would be only applicable if the body is uniformly accelerating. Here in this case, we are taking the body to be uniformly accelerating, so this formula will work, but it may change if it was not uniformly accelerating. So what is the answer of here? So let's take the variables. Instead of this, I have given you it was inertially moving with the speed v, and the final speed it was inertially moving with the speed inertial, and then it changes to final. So now what is the initial speed, that is the average speed? It is given by u, that was inertial, plus v by t. So this is when the body is uniformly accelerating. Here the time it is not given, so we have to divide it by 2, because it is the two variables are given it. If there was another time in which it was speed, you retain the speed of w, but in now you will not add these three observations and divide it by 2, but what you will do is, now if it is a uniformly accelerating, you will add v and w by and divide it by 2, and this total we get average speed of this and this, and total all divided by 2. So let's move to the second case, which could be formed by the speed. So in the case 2, what happens if now a body is covering s distance in s1 distance in t1 of the time, and then s2 distance in t2 of the time, and s3 distance in t3 of the time. So what is the average speed? So we know that speed of this would be s1 by t1, and speed of this would be s2 by t2, and this would be s3 by t3, that is velocity that is the velocity 3, velocity 2, and velocity 1, that is the speed 1. So now the another formula of this, it could be that the average is the total distance traveled by the total amount of time. So you could do it like that way, that is s1 plus s2 plus s3 divided by t1 plus t2 by t3. But in some cases, if the time intervals are same, that is t, t and t. So now what you can do is, we get the answer as 3t here, and you cancel the 3 out and take this at the outside, so multiply by 1 by 3. So this is the average distance, average speed traveled when the body is traveling with the distance in per unit of time. Now it question may ask to find out the speed at the time at what it took. So let's take, if the speed distance was s1 and it travels with the velocity of that is the speed of v1, and then s2 with the speed of v2, and s3 with the speed of v3. So what would be the average time here? So the time would be v1 by v2, that would be t1. So this time would be t1. Then it would be s2 by v2, that is t2, and s3 by s that is t3, that is t3. So all these have come from the which equation, that is speed speed is equals to distance divided by time. So this was another case. Let's see when the velocity and the speed are given, and we have to find out the distance traveled by it. So now what happens if we have a given of, there are three components in which the body was traveling with the speed of v1 for the t1 time, and then v2 with the time for t1 instead of t2, and with the speed of v2, v3 with the time t3. So now what will be the distance traveled? So distance traveled would be from the equation number second, that is d is equals to s into t. So speed is given as v1 into T1, that is V1 T1. So this would be the distance traveled by 1 plus this would be V2 by T2 and this would be V2 by V3 by T3. So this is the total distance traveled by the object. So let's move to the case number 5. Now what happens if a boy is going from a school to home and returns from this? So now his speed could vary, but the distance is same, that is S1 and S1, but his speed here let's it conclude as the V1, and when it was returning at the same distance it is V2. We know that the speed, average speed is total distance by total time. So we have is total distance by total time. But the time is not given. We know that how we can find out the time. The time is distance divided by speed. So S by V1, this would be the time of this, that is T1, and here it would be that is time 1, and S divided by V2, that would be time T2. So it takes the time T2 here. So it was traveling with the speed of S1. So total speed, total distance would be 2S, that is S and S, and we have given the time, that is T1 plus T2. Now we can put this value instead of T1 and T2, so which would be S divided by V1 plus S divided by V2. So this is how we can calculate when the body is traveling the same distance with different velocities. But if now it is said that if it is traveling with the same speed with the same distance, so what would be the average? We can directly know that it would be V by V would be T1, that is T of inertial, and that they will take a similar time, the T1 by T2, which would cancel it other out, and so the distance by the time would be the how we can calculate the average speed. Until now we are all talking about the distance, but in the previous part of the video we have seen a new term, that is the displacement, that is the shortest distance between any two points. So if it is a point A here and point B here, and the body goes from here to here and returns to B, so the path covered would be the distance, but the shortest path between this is known as displacement. We have talked about the distance by time, which is known as speed, but what is the displacement by time? What is the displacement time? That is known as the velocity. So we can say that velocity is the speed, but of the distance by time, displacement by time. So let's talk about the difference between the speeds and the velocities. So what is this difference between the speeds and velocities? So first we can see this is heavy speed and this is velocity. So first difference, it is written as the speed is equals to d by t. Here d stands for distance traveled, but here the velocity is displacement by time. So we know that anything distance is a scalar quantity, so the speed is known as a scalar quantity, and displacement is a vector quantity, so the velocity is also known as vector quantity. We know that speed distance always remains positive, so speed would also remain positive because time can never be negative, but the velocities could be positive as well as the negative, and the speed could remain 0 or positive only, but the velocities can be either negative or 0 or plus. So these were the all differences between the velocities and the speeds. So friends, this was the part second of the chapter motion. Hope you like this video, and at the last, thanks for watching.